Hello everyone, I am Dr. Abha Kumari, Assistant Professor, Nirmala College, Ranchi. Today our topic of discussion is from I.Sc Second Year Mathematics and the topic is System of Linear Equations. So let us first see what we mean by system of linear equation. Thus, a system of linear equations means if we have given 1, 2 or 3 linear equations, then combine all that linear equations together, we say that this all is a system of linear equations. Here I have taken an example of a1, x1 of all these. So these all equations together, we say that this is a system of linear equation. Okay. So to solve a system of linear equation, we have to find either the system of equation is consistent or inconsistent. Because if it is consistent, then we have one or more solution, and if it is inconsistent, then we have no solutions. So let us first understand what we mean by the consistent system of equation. A given system of equation is said to be consistent if it has one or more solution. One or more solutions. Okay? And second one is inconsistent system of equation. It means if a given system of equation is said to be inconsistent if it has no solution. Isn't it? If it has no solution, then we say that the system of equation is inconsistent. Okay. So let us see the method of solving a system of linear equations. How can we solve a system of linear equations? So the first is first we take a linear equations, either it is of the 2 equations or 3 equations or 4 equations and many more. So solving a system of linear equation, I have taken here the 3 linear equations, and the linear equations is of the form a1x plus b1y plus c1z equals to d1. Then next is a2x plus b2y plus c2z equals to d2. And third one is a3x plus b3y plus c3z equals to d3. So here we say that we choose A as a matrix and we put the elements of A as A1, B1, C1, that is the coefficient of X, coefficient of Y and the coefficient of Z. We choose all that coefficient as the first row elements. That means the elements of the first row. And the elements of the second row we will collect from the second linear equation. And the element of the third row we will collect from the third linear equation. So here in this way, we first construct a matrix A and we put that element A1, B1, C1, A2, B2, C2, A3, B3, C3 as matrix A. And thereafter we use the capital X as the variable used in the linear equation. If it is the 3 variable used in the equation, then we will write x, y, z. If the 4 variable are used in the equation, then we write x, y, z and whatever be the fourth one. Okay, in this way. But we will write in a column. And thereafter, the constant value which in the right hand side, we just pick them values and write the matrix B as D1, D2, D3. Again, this is a what? 3 cross 1 matrix. Okay, but a column matrix. So after picking these values A, X and B, we write that the system of linear equation can be written in the form of this one, this way. And this implies Ax equal to be Yax because A is this one. So we put the value of A here. So write it here. The X is here. So we write X. And thereafter we write it here B. Okay. So in this way we write the values 1, 2 and A, X and then B. Okay. So this implies X equals to what? A inverse B. So here the 3 cases arises. The case 1. So what the case 1 is? So case 1 says that when the system of the linear equation, that is mod A, not equals to 0. Okay, from here if we choose the mod A and mod A from here, if it is not equals to 0, from here if the mod A, this value is not equal to 0 and x equal to A inverse B we are finding here, so find x equal to A inverse B, then if A inverse is unique, then the given system has unique solution, and since mod A not equal to 0, so the given system is is consistent. Very important, if mod A equals not equals to 0, then the system of equation is consistent. Okay, now case 2. When mod A equals to 0 and adjoint of A into B not equals to 0, then the system has no solution and hence it is inconsistent. Okay, if the mod A equals to 0, then it is inconsistent. Very, very important. Case 3. When mod A equals to 0 and adjoint of A into B not equals to 0, then the given system has infinitely many solutions. So here the three things we have to remember, and the things are, first one, mod A not equal to 0, and what, x equal to A inverse B, then A inverse is a unique. Okay, then the system is consistent and has unique solution. Number 2, if mod A equals to 0 and adjoint of A into B not equals to 0, then the system has inconsistent and has no solution. Third, if mod A equals to 0 and adjoint of A into B equals to 0, then the system has infinitely many solutions. Okay, so let's see some problem from this question. So I have picked this question. Use the matrix method to solve so that the following system of equation is inconsistent. Okay, I have picked this question. So the matrices of the linear equations are 2x plus 5y equal to 7 and 6x plus 15y equals to 13. Let us solve this question. First, we write the given system equations are 2x plus 5y equal to 7 and 6x plus 15y equals to 13. So first what we do, we first pick the value of the matrix A, then value of the matrix B and also x. Okay, so now, so A equals to what? 2, 5, 6, 15. Capital X is x into x and then y, and capital B is 7 and 13. Okay, after picking this value, what we do? We write it in the form of Ax equals to B. So now we find A mod A. So what is mod A? Mod A is 2, 6, 5, 15, and by solving this we get 30 minus 30, that is equals to 0. So here the mod A equals to 0. Thus the system will be inconsistent. Very important. The mod A is what? 0. So the system will be inconsistent. But in inconsistence we have two values. One is if adjoint of A into B equal to 0, and second one is adjoint of A into B not equals to 0. Okay, so the value of the system will be inconsistent if adjoint of A into B not equal to 0. Here we have not to find the value of the linear equations, we only have to show that the solutions are consistent or inconsistent. Okay, that's why we choose adjoint of A into B not equals to 0. Okay, yeah. So the cofactor of the elements of A, I am not going to solve the cofactors since I have done lots of problem earlier in the lectures. So I am just writing directly the what are the cofactors of the elements of A. So A11 is 15, A12 is minus 6, A21 is minus 5 and A22 equals to 2. Therefore adjoint of A equals to. So what the adjoint of A is? 15 minus 6 minus 5 and 2, and then इसका भी क्या आपको लेने हैं ट्रांसपोज, तो ये हमें मिल गया 15 minus 6 minus 5 and then 2. Okay, now the adjoint of A into B next we have to find. So writing in this way, first we write the value of adjoint of A and thereafter the value of B. So while multiplying this value, what we get? 15 into 7 plus minus 5 into 13, and thereafter minus 6 into 7 plus 2 into 13. So this will give the value 40 and minus 16. Since we have some value here, it is not equals to 0 and 0. That's why we will write it not equals to 0. And hence, since mod A equals to 0 and adjoint of n to be not equal to 0. So hence the given system of equation is inconsistent, and hence we have proved this question. So in the next lecture we will find the solution of the system of linear equations. Okay, so thank you. आई होप आपको ये वीडियो अच्छा लगा हो और आपको समझ में आया हो, तो आप प्लीज़ वीडियो को लाइक और सब्सक्राइब ज़रूर करें ताकि ये और भी जो बच्चे हैं जिनको नीड है उन तक ये पहुंच सके. थैंक यू ऑल.